So I welcome back all the participants for the second keynote session for this conference on SDG, which is going to be delivered by Engineer E. Syed Ibrahim, Head of Technology Solutions India Private Limited, Coimbatore, India. Emerging technological trends for Industry 5.2. Over to you.
Yes. Can you see my screen, everyone?
Yes,
Your
sir.
screen is visible, sir.
Yes, is it visible? And can you all hear me? I hope, yeah? Can you hear me?
Yes, sir.
All right. It was really a nice session with Mr. Raja. And here we are to discuss about the emerging technological trends for Industry 5.0. And I'm Syed from Enthu Technology Solutions India Private Limited, basically an R&D company. And I'm the technical lead. Here I'll be discussing some vital points on what we are going to foresee in Industry 5.0. And generally, we all have heard about this revolution of connectivity. There is Industry 4.0, where lots of things have been introduced. And what are we expecting on industry? It's going to be a emerging phase of industrialization, as we are already aware. Society is going to be working alongside with AI-based advanced technologies. At least, for example, we could say we are going to be working on AI-based. Why do we go for all this? Is we are going to do things in a smart way. That's why we are going on to this. And if we do things in a smart way, obviously we'll get the efficiency. Discuss all these first three vital points, and finally I'll give some brief on our company. And initially, we are going to have a discussion on LoRaWAN based IoT. You might have heard about Internet of Things, that is IoT. Generally, what we are using now is LoRa IoT. There is a difference between LoRa and LoRaWAN, where LoRa is the long range, as the name says, long range. That is what LoRa is. A network. And how are we going to connect these two technological aspects like LoRa and we know this, yeah? We are going to connect all our applications to the computer and control applications. And there are lots of applications nowadays getting controlled from our computer. And this is how internet has, 15, and is going to be like this for the next two. This is how the Internet of Things works. So you can see, that we are all aware of for storing our energy. Like we have got, and it storage where we can store our information and then we can access. If I have a cloud ID, then I only can access this information. So that's what exactly happened with IoT, which is based on LoRa. With LoRa, there is no encryption, there is no protection at all, which means you can simply transfer the data to see what's happening, just like what so he was talking about some Arduino boards later. So it was a vital point that he has already defined this thing, and we are going to see what are all the advanced features nowadays available next to this Arduino stuff. So here you can see the cloud, and this is your thing and your application, where Web of Thing API is with incorporated with this thing, and we are connecting our things to the cloud. That's where getting, encrypted and interesting. So here, anybody who is trying to access this information is away from this cloud stuff and the gateway information, stopped from accessing the thing, but which means only the authorized person can use it. So here, you can see all platforms.
Sir,
Yes,
screen is not visible, sir. Only the window is visible, sir. PPT is not visible.
just a
I
moment,
think
sir.
you
Just
have given a select a tab option, sir. You can give the entire screen as option. So stop share and give.
just a moment, sir.
Yeah. Dear participants, I think you would have find the query and you can have presented on behalf of you. I want you to be interactive if possible, because this is not yet another program. Okay,
Yes, yes,
based upon the feedback from the students only, we are organizing various programs through our platforms. So be
yes.
option, sir.
Just a moment, sir. Is it visible now, sir?
Yeah, now it is visible.
Should I go previous slide? I think a
Yeah, you
couple
can
of slides.
continue. It is clear,
Just a
sir. The
couple of slides.
data I thought that it were not available, sir. So only
Fine,
info.
fine,
You can continue, sir.
fine, fine, fine. We have not discussed nothing, nothing much on the previous slide. Introduction to the IoT architecture, and you can see this cloud platform over here, and this is our application which is connected through
You
this
can
gateway.
put the full
Fine.
now.
Is it visible now, sir?
Now it is okay, sir. You can also give that hide. Click the hide button on the near the
Oh,
stop share
this one.
button.
Yeah, got it, got it.
Yeah.
Okay, sir.
Now it
Is
is
it
fine.
visible? All right, all right. So very simple. You see, this cloud is a place in the internet where you will be creating an account that is an electronic component exclusively designed to receive a certain frequency, and it is transferred to the cloud. That I'll explain. So this is the general architecture of IoT, so for your information, and this all cloud platforms where you can see the Things Network, the Ubisoft ThingsSpeak. These are all open source platforms available on the internet. And the ThingsMate is our own product, which is subscription based, where you have both network and application. So first, the difference between these two, like the Things Network, ThingsSpeak, Ubisoft, and the ThingsMate. So these are all can be subscribed on annual or monthly basis. The only difference between going for open subscription based platform is the history of data be available with the open source thing, one. And the other important thing, the speed of response, I should say. That is, when you're trying to access platform on open source, you know what it is, how the free stuff works. So it's going, but the Things Network or the Things Made or Things Pay, if you're going for the subscription based thing, then the speed of response, it's really good. So that's what we want. So here we go with communication, which we might have heard about all this Bluetooth. See, this Bluetooth and the Thread Zigbee stuff. These are distance like few meters. And obviously this thing. This is our communication stuff, and so so we know all this. But what we are focusing now is this LoRa, Sigfox, and NB-IoT. And today exclusively we will discuss on this LoRa thing. So LoRa WAN, which is long range wide area network. So which can give you up to a reach of 10 kilometers from your application. Like I said here, you can see the cloud, it is there. It's on the internet. And the gateway will take the signal from your application. So the distance between these two, the gateway and your we are going with this LP WAN, this is LoRa WAN. It can be up to 10 kilometers for outdoor. For indoor, it can be up to 2 kilometers. I'll explain that. Here we go. The basic difference between this LoRa and LoRaWAN communication technique, which is having a range of around 800 meters, it comes under IS, and that is industry scientific, where spectrum, the technology is chip spread spectrum, which will be addressed later on, which you may, for in the next week, we'll be addressing some problems related with this chip spread spectrum. So this by Cyclio France, but later was acquired by Semtech California. Now, Semtech is one of the main organizers and the managing body of this LoRa. So coming to LoRa One, it is an exclusive communication of telecommunication union, and the standard they have developed a standard, mentioned it for exclusive LoRaWAN communication. Which lots of frequency bandwidths are coming for each and every country. They are not regions like Europe, Asian, like that. For India and China, we have separate frequency bands, right? Established by the LoRa Alliance. These solutions is one of the LoRa members in India. Only few members are there. We are one of them. Communication is very, very low, which means that it does not data for its operation. There could be multiple channels. This number of channels, as you can see, up to 50 kilobit per second per channel. Before, over here we have a gateway. This gateway, right now, what we have we are using is 8-channel gateway, which means that for one channel we'll be using just up to 50 kilobits per second. So for 8-channel, you can calculate. It's only a small amount of data, where we are dealing with gigabytes of data internet usage. And the protocol that we use is the cloud MAC protocol. You know about cloud and the MAC, the physics of your system is working with LoRaWAN. Different classes of LoRaWAN, A, B, and C, which is classified based on power supply needed for its operation. And first two, they are the first two, A and B, they are battery operated, where A is widely used only just uplink, which uplink means over here, told you, from the cloud to the communication between your application and the cloud. That is, the signal is going from the application and gateway and to the cloud. This is what uplink is. Whereas downlink is if you want to control your application from the cloud with the pre-written commands, you can see that is what downlink is. Here, the class B, the class A allows only one uplink and two downlink at a time, whereas the class B gives additional receive windows actually, which means receive windows in the sense either for uplink or downlink, both. It depends on the programming that we incorporate on the processor. And class C, as we all know, like it's continuously powered, like our electricity connection to our home or something like that. It is continuously powered and it is available 24/7 for communication. So this picture shows a clear idea of typical LoRaWAN architecture, where the end nodes is your application. See, trash container, vending machine, water meter, whatever, and this application is connected to this gateway through a processor, like what Sir Raja was saying earlier. Arduino board. He was talking about Arduino board, where you can sense some signal and take it, display it. So instead of displaying it on a computer peripheral or direct hardware, we are going to take this signal from our end node to the application server. That is our laptop cloud, on your laptop or mobile phone or a desktop computer. We are going to access the information over here, available over here, the application server, to give a command back to this end application. Yes, we can do it by using this architecture. And the gateway plays a major role. And between the application and gateway, there will be a processor like Arduino or some other processor, that I will explain. But the main advantage of LoRaWAN is, you can see the last point, secured with 128-bit advanced encryption standard based encryption, which means the information from the application, see, from the end node to the concentrator will be a signal of a radio frequency range. Like for India, you can see here 865 to 867 megahertz. So this frequency, this bandwidth is allocated for India for this radio RF communication, as well as LoRaWAN architecture is concerned. No other people is going, none of the other sectors are going to use this ISM band. So the reception of RF signals at this point, you see over here at the gateway, is encrypted, and this encryption takes place at the processor. So this is our application. I hope you can see this end node. Can you all see this end node? Am I am I audible to you all? Can you see this end node?
Yes, sir.
Yes. And between the end node and the gateway, we have a processor where things getting really interested. And you can see these are all basic advantages like low power and internet connected applications. But the range, like I told you before, is between 2 and 10 kilometers, depending upon the type of gateway used, which we will see in the next slides. This is for much better understanding where things have started from right to left. So this is application, LoRa node. This is our processor, the gateway, and the cloud. As simple as that. The encryption level. Before we see this encryption level, I just want to tell you about this activation methods. The reason why I put this slide before and after this one is to give importance to this encryption level. You can see this is our device and this is our application server on our computer or desktop, desktop or laptop computer, where different types of encryption levels are there. You see network session key, application session key, and see this is generalized encryption for LoRaWAN communication, and it is purely depending on the type of activation we use. For example, if you're going with OTA, that is over the air activation, which is generally preferred because it has a very good encryption standard and the safety level, the encryption level is highly appreciated and effective as well. And where we will be using three different information from the cloud. Like, see, we are connecting our application to the cloud through a processor and gateway. This is as simple as that. Like I told you before, see, over here application, the cloud. So we are going to get the information about our application on this cloud, and it is connected through a processor and a gateway. So this processor sends a radio frequency signal which can only be received by this LoRa gateway, and this LoRa gateway sends the signal to the cloud. All right, this is the basic of this LoRaWAN architecture. And now from the cloud we'll be using all these three information if we are going for this over the air activation method. So device EUI, it is the device extended unique identifier, and similarly the application stuff and the application key. So these two will be 8 bytes, and this is going to be 16 bytes of hexadecimal code. So the reason why we go for hexadecimal, you know that, yeah. And for activation by personalization, there will be three other different keys. So see, depending upon the activation method that we use, so we'll be writing our program on which will be uploaded on our processor. All right, and the processor is directly connected with the application through wires, and it is connected over the air with the gateway and the cloud. And we have to register this gateway before we start using it on the cloud, and this is how it is registered with all these three keys: application, device, and gateway EUI. Plus, you can see this LoRa gateway is manufactured by Dragino, who is one of the partners of our company, located in China. So they have their website where we have to register our gateway. Like when we buy a SIM card, it is from Jio or Airtel or something. So we buy the SIM card, but still we have to activate it. Just like that, the gateway, we buy it from Dragino, and still we have to register it before we start using it. This is a generalized picture of what is LoRaWAN is. So So you can see the long range lifetime, cost and multiple usage. So this is how we have installed a gateway near our company. So this is an approximate view. And though this LoRaWAN has lots of advantages like longer distance, reduced loss, and other stuff, more importantly, you can see secured, 128 bits of AES encryption. So I have seen lots of students working on this LoRa projects, sending the data to cloud platform, which is called ThinkSpeak. You must have heard about ThinkSpeak, which is given by, uh, recently acquired by MathWorks, and there you don't have any encryption. Still, you just have to buy the ESP32 processor. You just need to program it and install the library for ThinkSpeak, and you can directly see the data on ThinkSpeak. The thing is, it's connected with internet. Like you have to energize the board with internet connection, as well as you must have a cloud platform on Things network. But it is not secure at all because you can give talkback command to control your device, but there is no encryption involved. But the that's not coming under LoRaWAN. It's coming under LoRa, but not LoRaWAN. But LoRaWAN has major advantages. One of the major advantages is this encryption standard. But still, it is not used, suitable for these kind of applications where we can understand the image and video transfer. We cannot do it with the LoRaWAN. And regular voice call, you know what it is. But critical system, coming back to this critical system, is something we should think about, because if we are able to introduce this LoRaWAN into critical system, it will be a very big achievement. But we don't want to risk, because the critical system stands here. What we mean is dealing with lives, like maybe human lives or animals, whatever. Where the patient monitoring, because APM is the patient monitoring system, there we are not advising this, suggesting this LoRaWAN. You know what happens with, as you see, this LoRaWAN is completely working on internet stuff. See, the board, the gateway, and the cloud both are working on cloud, internet based. So the problems with the internet connection. So we cannot risk by introducing this LoRaWAN on critical systems. Let's see, how do we interface LoRaWAN and real life applications? See, we are completely discussing on Internet of Things with LoRaWAN, which is one of the major things which we may have to focus on working on Industry 5.0. These applications, these techniques, LoRaWAN based, AI based techniques have already been discussed in 4.0, and it is slowly going on. How do we get it a little bit faster and get associated with this thing? That's where we are focusing on this. So please understand that we are focusing only a single part of this 5.0 technological development stuff. And interfacing LoRaWAN and real life application, like Sir Raja said, he has just gave an introduction on Arduino. I'm really happy, and so that we can get started right away. You can see here is the Arduino board that Sir Raja was talking about. So he was saying interfacing some sensors. This is an ultrasonic sensor which can be interfaced with this Arduino UNO board with through these pins and some connecting wires. All right, this is a well understood stuff that we all are know. We all are aware of all this stuff. But what I am going to tell you now is, you have a certain information over here which can be transferred to this cloud. ThingsMate is a cloud, okay? Like ThingsSpeak, the Things network, like I told you here. See, like this. So I am just mentioning ThingsMate, which is our product. I mean, our own cloud server, and these two are available in market. You see, listen very carefully, please. So we are connecting this sensor with the board. It's typical. You will be writing a program and get it uploaded on this Arduino UNO processor. All right. Now, what we have here is called LoRa Shield, which means you can see a set of processors and other associated components here. This will transfer the processed signal from here. Actually, we are going to fix this on this so that it is called a LoRa Shield. In market, this LoRa Shield is not available. LoRa Arduino boards are available, not the LoRa Shield. LoRa Shield, the gateway, and the cloud together, it forms LoRaWAN architecture. All right. So here, this is a typical microcontroller where you can do some processing of sensor or some other application. This information over here can be taken to the cloud, from where you can give written command to control your application. And that's what this is so special on about. And this LoRa unit, RF unit, we call it RF unit, the radio frequency unit. The signal processed on this, is given to, this RF unit modulates this signal and sends it to the gateway. The modulation, RF modulation, you all know what is RF modulation is. So this signal is combined with the carrier signal and is sent to this gateway. So this gateway then transfers the information to the cloud. These two are connected. I told you already the gateway registration. See at the bottom of this slide. Using these three keys, we'll register this gateway on this and also the Dragino website, so that this gateway is active for usage, connected with the cloud. And now I think you understand the logic. Do you understand the logic, or should I repeat this logic? Can you hear me? Can you hear me?
Yes, sir. Audible, sir.
Sir.
Yes. And I repeat the process. So the sensor is your application. It is connected directly with wires to this microcontroller board. And this microcontroller board, the signal processed on this microcontroller board is modulated with the signal of this RF unit and sent via this antenna to this gateway. This gateway sends the signal to ThinkSmith. This is the basics of LoRaWAN architecture. All right. Now, how do we connect this cloud and the device? Now, one-way communication is done. How do we connect this cloud to the board? That I'll explain. So before we start using this cloud thing, we have to create an application. Like this is ultrasonic sensor. You may create an application called ultrasonic sensor experiment or a project or product, whatever, on this ThinkSmith cloud platform, where you'll be getting the important keys, the three keys, like I told. Just a moment. Can you hear me now? Can you hear me?
Sir, audible, sir.
Yes.
Yes, sir.
Thank you. I told. The cloud platform, and these three keys are taken with code. We upload a program depending upon our application. We'll be uploading a program over here, and we create the application, and then take these three keys and put it on the program, so that this is connected. This is a loop.
Sir, your voice is not clear, sir. It is something breaking, sir. Your voice is breaking, sir.
Have you understood?
Sir, can you hear me? Your voice is breaking, sir. There is some network issue, sir. No, sir. Your voice is somewhat breaking, and it is. You can cut and rejoin, sir. You can rejoin again. You can rejoin, sir. You can rejoin again. You can. No, sir. There is some network issue, sir. You can leave and rejoin again, sir. You can leave the meeting and rejoin again.
Everyone?
Hello. The presentation is visible, sir. Voice is lagging, sir. You can cut and rejoin again, sir.
I'm not getting any response.
Can you hear me? Hello?
Hello, Rajarajan sir.
Sir, you can cut and rejoin, sir.
Can you hear me? Sir, is my voice audible?
Sir, you can leave and rejoin again. No, your voice is not audible. Dear participants, due to some technical glitch, Sarah has left out. We will wait for 1 more minute so that he will rejoin back. So, yes, sir, you can
you
speak
hear me
now. Speak now, sir.
Can you hear me, sir?
You can remove that audio, sir, that headphone, and you can speak, sir. You can speak now, sir. Unmute
Is
and
it
speak, sir.
audible, sir?
Unmute and speak.
Yes, sir. Sorry for the
Now it
interruption.
is clear, sir.
Shall we go on with the presentation now?
You can share. Yes, sir.
Yes,
You
please,
can
just a
continue,
minute.
sir.
Is it visible, sir?
Not at shared, sir.
I've shared it. Yeah, just yeah. Now, sir, is it okay?
Now it is okay, sir. You can go for full screen mode and continue.
Coming up, sir, right away. All right, sir.
Yes, sir. 10 more minutes left, sir. Time is 11:40 nearing. 10 more minutes.
Yeah, we can do it, sir. We can do it, sir. We are almost at the end. We can do it still.
Okay, sir.
Okay,
Thank you, sir.
sir. Shall I proceed? Yeah, welcome, sir. Shall I proceed?
Yes, sir. Yes, sir.
Yes, yes. And have you all listened to this thing that I was explaining? Should I repeat? Like this is basic example.
You can continue.
Yes, yes. This is basic example that how do we interface a sensor, this sensor with microcontroller, which was introduced, given Mr. Raja has given an overview on this, but still, how do we take this thing, the processed information over here to the cloud is through this gateway and this LoRa unit. So the process signal is modulated over here and is transferred to the gateway. The gateway simply sends the signal to the cloud. Also, from the cloud, we can take the command back to this device, whether we want to operate this device or something. So this is really useful in case of UAVs. Just we were discussing a moment ago, the unmanned armored vehicle, and also the drones, you can say, on-air drones, where we'll be having some motors. These motors can be controlled from the ground or wherever we are from. Wherever we are in the world, we can control the things. Like even our home applications or home appliances or agricultural applications, we can control them, or industrial applications, whatever. We can control them from anywhere in the world, right? This is how it is done. So these two things, the sensor and the microcontroller, these two are wired. From here it goes wireless, right? This is the basic. And the processor that we are seeing next to the Arduino board is the level 2 processor, that is ESP32, is generally available in market. But here with the LoRa unit, we developed a module. Enthu Technology has developed a module like this one, so which will be doing all the process. Like this ESP32, as we all know, has an inbuilt Wi-Fi and Bluetooth module, and also it has onboard temperature sensor, which is used for study purpose, right? For example. And where are all these applications deployed? I'll show you. This is the outdoor gateway, which has a typical range of 10 kilometers in case of desert areas, but for inside cities, we observed up to like 4.5 kilometers range. That the distance from the gateway to the application, between the gateway and application, the distance is 4.5 kilometers. I hope you can understand. This gateway will send the signal directly to the cloud, and this gateway requires an active internet connection for functioning, right? This is one of the agricultural applications, like for irrigation, smart irrigation. So depending upon the type of seed planted, we have to maintain moisture level, right? Where we have installed moisture sensors, and the moisture sensors data is taken to the cloud based on the moisture level at the moment. The pump needs to be turned on and off. That's what we have done here. This is another application, like with, actually we are not controlling the soil moisture, temperature and EC control, but electrical conductivity, but we are taking the sensed values and we are giving control command to the device that controls the soil moisture unit or temperature control, whatever. And water monitoring as well. See, these are the sensors available readily in market, and the sensitivity of the sensor depends upon the type of where we use it. It really varies. Like for example, the pH sensor, which can even be bought for like 3,000 rupees, but still varies up to 1.5 lakhs. So depending upon the application, the sensor is selected, and the sensor's data. Once you have the sensor, we know what is sensor. Yeah, it's going to be converting a physical quantity into equivalent electrical signal. And this sensor, if you have the sensor, yes, you're done with this architecture. You can connect it to the cloud using the gateway and the suitable microcontroller. So this is a level sensor. As you can see, this level sensor is here. It is connected with this wireless unit, and this unit will transfer the information to the gateway. Okay, this is where the processor is. So the sensor, processor, and it's taken to the cloud. Another application. Same application of different, area. Same device, different application. Again, here for boiler we need to maintain all these things. You can see temperature, water level. For temperature, we have onboard temperature sensor with the ESP32 microcontroller that I have shown you a moment ago, and the automatic water level monitoring. Like this, we have water level monitoring sensors, and it is installed for this boiler, and the things can be taken, the sensed signals can be taken to the cloud and processed. Another application, since we are running short of time, let us show you the applications where we could use all this. And the main thing, wind turbine. So all the mechanical and electrical signals, equivalent signals, can be sensed and taken to the cloud for monitoring this wind turbine. If we are in need of shutting down this, due to the high velocity of blades or some other reasons, if we need to shut this down, yes, we can do it from the cloud. And this is for domestic and industrial applications, where in our homes we are using this um, water meters. Generally, the water meter given by municipal, we are using it. But here, this has an inbuilt unit, LoRa unit with battery, and it is connected with the water connection from the municipal to the home. Between our home and the municipal connection, this meter is fixed, and it is capable of working up to a period of 5 years with the battery, and the inbuilt LoRa unit is there. So you just need to connect it and get it connected with the cloud. That's it. All the information on your water accumulation or whatever, the consumption, and what is the current level of water, everything will be displayed on your dashboard on the computer. And another application with temperature sensor for either for room temperature monitoring, or you can see heat, ventilation, and air condition control. So with this, we'll be using a sensor, a temperature sensor, which has a very high sensitivity. All right. So I'll skip this. Oh, this is how a typical dashboard looks like, on your cloud platform. So where you can see things and you can change the widgets like just the way you want it to be. Weather monitoring, feedback device, everything is wireless nowadays. And parking occupancy, you can see even we have installed it in one of the institutions in Tamil Nadu. And this is in our company. Where here we have used PIR sensor. Only the sensor varies with the applications. You know what I mean? You change the sensors and the coding correspondingly. So the program and the sensor, these two are going to be changed, and the application remains controlled. IoT solution for poultry farms. We have done all this stuff. As you can see, all these things can be monitored. So I think we're running short of time. Here we go with in textile industries. Despite we have seen lots of applications so far, and this textile industry is something different where you need to maintain lots of real-time data. So for this, you can see ESG and NVGGR. These are all the reporting indexes that we generally use, which comes under the NVG is nothing but the national voluntary guidelines, and GR is the another reporting. What are all the company's data, like which is related with the environmental uh, aspects, needs to be recorded and maintained for review. So if we review our own company's data, then we will develop so that the environment is clean and green. That way this IoT plays a major role. What is this typical, these two are same, but the energy involved is different. All right. Also here we can use this IoT stuff. Energy meter, smart energy meter for our domestic and industrial applications. Inside this energy meter, the LoRa module is there. So all your consumption, whatever happening with your electricity line, will be taken to your cloud like this. This is the dashboard. Like this, it will be taken to you. You can see wherever you are. You can see it from your cloud database, especially for a big industry, where you'll be having lots of processing units and production units. This plays a vital role, and they have started deploying it. Right. And this is an overview of what IoT is capable of. See, smart cities, parking bin, all this stuff we can implement. It only depends on the type of sensor that we select. Right. And a short note on what we are doing at the moment. We're doing all these four processes. These are our verticals. So EMS, electronics manufacturing and service, where we have our own production machines, AI based production machines, which will be printing the boards on its own depending upon the program that we feed. Like CNC, we heard about CNC, but here we have a pick and place machine, which is SMT, surface mount technology made products. So the robot will be working on its own. Like for a minute, we'll be placing nearly 20,000 components on a big batch board. As you know, the PCB process is a batch process. Our robot AI based machine is capable of placing 20,000 components per minute. Sorry, per hour. And Internet of Things. We have IoT products, consultancy services, and all that stuff. So we are working on lots of real life projects, which I have shown you already. And still we are working on two big agriculture products at the moment, completely based on LoRaWAN architecture technology. And academy solutions. This is where we are connected with the educational institutions, where we train the students as well as the faculty members. we give some inputs to the faculty members. We train the students completely to develop a project, which is depending upon the duration that they prefer. Apart from all this, now we are developing applications. Actually, we have a cloud platform where you can see the data, but that data is taken to mobile application that we are working on. All right. So these are all verticals, and these are our trademark products. And we have some acknowledgements from government of Tamil Nadu recently. We are the bronze partner for this event. Happened last month, like 10 days ago. I hope you are all aware of it. And we have received an award at Orlando for our, you can see, for the 2022 contribution. Like we have innovated few real life applications. I mean, we have innovated the real life application into this LoRaWAN technology, and we have got awarded, right? And this is a very big acknowledgement from ICT Academy of Tamil Nadu, which is really, really highly useful for connecting industry and the educational institutions. So ICT is playing a major role, and we are one of the proud partners of ICT Academy team. And these are all esteemed partners, you can see, from China, Sweden, and Lithuania. Especially recently, we have signed up an MOU with GoLSR, United States of America, and Gorilla Link Israel. They are now, see, so far we have discussed on Internet of Things. They have gone to satellite of things, I should say. They have started controlling things from satellite for individual application. They have started to connect the applications with satellite. So they are on to next level. So we have signed up an MOU with them, and we have started working on satellite communication as well. And these are all our partners, clients from educational side sector. And if the student is really interested to go on some training, we suggest to go on all this. So being a technical, one of the technical members, I suggest the students may go on practicing all these things. So for to practice the requirements for 5.0, industry 5.0, the next level engineers need to work on all these things. And I'll be finishing my presentation with this. If you have any queries, you may please post on. Rajarajan sir.
Thank you, sir.
Thank you, sir. Thank you. I think I've completed at the right time. Yes, sir.
Yes, sir. Yes, sir. We're completed at the right time, sir.
Thank you. Thank you so much. Thank you.
And I think my ID is showing as Rajarajan, sir. My name is Rajashekar.
Oh, my pleasure. I'm sorry.
This ID we have that paid for recording, so I joined this ID.
Fine, sir. Fine, sir.
Dear students, if you have any queries regarding the IoTs, which is a key important part they have discussed on the LoRaWAN technology for 5.0, you can ask to sir, or else if you have no doubts, you can post in the comment section as no doubt, and the recordings will be shared to you for the future reference. The first session we covered the UAV stuff, the aircraft design technology, and now we have covered IoT. And both the things are very important for nowadays for any technological entrepreneurs. Without a PCB boards or IoTs or programming stuffs, you can't develop any projects regarding the technology today. So both the sessions are planned in the that perspective. Thank you. I think no doubts from the students, sir. And as you said, we are organizing internships in collaboration with the Enthu technology.
Oh, that's
And
great,
we are
sir.
also planning one summer internship through online platform and physical visit 1 or 2 days at the Enthu Tech focused on IoT using LoRaWAN technology. It will be rolled out within 15 days time for
Great,
student registration. Thank you, sir.
great. Thank you. Thank you. My pleasure, sir.
Stop recording this session,
Fine.
sir.
Fine, sir. Fine, sir. Thank you all.
Thank you, sir.